Okay, so let's start with our next chapter today, chapter 4, which is chemical bonding. Right? What do we understand by the term bond? Bond basically means attraction. Right? Binding one to another. That is what a bond means. Now, basically we know that according to Dalton, atom is the smallest element, the smallest part of any matter. Okay, therefore it is not stable. Thus we say that atoms combine to form molecules. Okay, what is this combination going to be? There are many possible ways by which atoms they can combine. Either they can combine with sharing electrons with others, or they can combine with transfer of electrons, or they can also combine by giving both the electrons by one atom only, that is also sharing of electrons. Okay, now this sharing or transfer or donating of electrons, that forms a kind of attraction between the atoms, and this attraction that is known as the bond. Okay, so when we are talking of bond, we say that there is some aggregation of atoms taking place, and this aggregation of atoms, this is known as what? It is known as molecules. The aggregation or cluster of atoms together, that is equal to what? That is equal to molecules. Okay, so there was a theory which was given for binding of atoms together to form cluster of molecules, which was known as the modern theory of bonding. Which was known as the modern theory of bonding, and this modern theory of bonding, that was correlated to valency of the atom. Valency of the atom. Now we know that, what do we understand by the term valency? In simple words, valency, that is known as combining capacity of any atom. This is what you have studied in the junior classes. Combining capacity of any atom. Okay. Now because it is the combining capacity, so valency majorly depends upon what? That is going to depend upon the valence electrons. Valence, the number of valence electrons, and valence electrons, they are the electrons which are present in the valence shell. And valence shell is what? It is the outermost shell which is present in any atom. Okay, so we are saying that the chemical combination of the atoms, that will depend upon the valency. Valency depends upon the number of valence electrons, and valence electrons are the electrons which are present in the outermost shell of any atom. Okay, so when we are talking of valency, modern concept believes that electrons, they are responsible for combination of atoms. So this is another important thing, that electrons are responsible for the bonding in atoms. Okay, so basically we also know that when we are talking of chemical reactions, in chemical reactions also it is the outermost electrons which participate in the chemical reactions, and similarly it is the electrons in the valence shell which are responsible for the chemical bondage of atoms to form cluster of molecules. Now the question comes, what is the cause of bonding? Why do atoms combine? Why do atoms combine to form a bond? There are two concepts given over here. The first concept, that is decrease in energy. That is decrease in energy. Now we know that if any system has less energy, that system is going to be more stable. Okay, so whenever bonding is going to take place, there is a loss of energy which is taking place because of the atoms coming together. When the atoms they are coming together, there are two types of forces which are playing. Number one, that is known as the forces of attraction. Forces of attraction that is going to be between the opposite charges, and the other one is forces of repulsion, which is between the similar charges, right? Now we have it is apprehended that whenever the forces of attraction they are going to be greater than the repulsive forces, only then the bond formation that is going to take place. Or in other words, we can say that whenever there is repulsion between the molecules, in that case there is certain repulsion energy, repulsion between the atoms, there is certain repulsion energy which is going to be progressive in nature, as a result of which the energy of the system, repulsive energy is what? The energy which is going to be released. So the system that is losing energy. Because the system is losing energy, therefore the bond formation can easily take place. Right? So what are we saying? That whenever two bonds they approach each other, there are new forces of attraction and new forces of repulsion which are taking place. The forces of attraction that is going to be in between the forces of attraction are going to be in between the opposite charges, that is electrons and neutrons, right? And the forces of repulsion are going to be in the similar charges, that is either electrons they are repelling each other, or neutrons and neutrons they are repelling each other. So if we say that if the resultant forces, that is forces of attraction, they are greater than the forces of repulsion, only then there is going to be a decrease in energy, and which results in the formation of a bond, right? The second cause is Lewis octet rule. Okay, now we know that the noble gases, they are very stable. They all exist in atomic forms. The noble gases are stable because they have a stable electronic configuration. Stable electronic configuration of 8 electrons in the outermost shell. Okay, 8 electrons in the valence shell. Because of these 8 electrons, there is no tendency for the noble gases to either attract or to remove or to donate electrons. Okay, so Lewis and Kossel, there were two scientists who suggested that any atom would prefer to form a bond if it wants to attain the noble electronic configuration or the stable electronic configuration of 8 electrons in the outermost shell, and that was known as what? That was known as the octet rule. So basically octet rule is what? It is the ability or tendency of any atom to attain a noble gas configuration of 8 electrons in the outermost shell. Okay. Now atoms they have an urge to go to this 8 electron system. That is the reason why either they will share electrons with others in order to attain a noble gas configuration, or they will transfer, that is they will donate or they will accept electrons in order to attain the octet rule. But there were 2-3 exceptions to the octet rule which were then explained on the basis of decrease in energy. What were these objections, or you can say exceptions? Exceptions to octet rule. Exceptions octet rule के क्या थे? The first one was hydrogen forms a duplet because it can only accommodate at the maximum of 2 electrons in the outermost shell. Therefore, it does not follow the octet rule. Then second, there were certain compounds like BF3 in which there were 6 electrons in the outermost shell. ठीक है, 6 electrons in the outermost shell, but still it was stable, right? So such octets, such systems which have less than 8 electrons in the outermost shell, they are said to be deficient octets. ठीक है, those which will have less than 8 electrons in the outermost shell, but still they form a stable molecules. They are said to be deficient octets, right? Then third, there were certain molecules like SF6 which had 10 electrons in the outermost shell, 12 electrons in the outermost shell. Still it was stable. So such octets, they are known as axis octets. Axis octets. Due to the violations which we are doing over here, the 3 violations to the octet rule, still the atoms, they were combining to form molecules. For that, the second reason that was given, that the system that was losing energy when the bond formation was taking place, and hence the bonding that was done. Okay, so this is our this thing. Then when we are talking of Lewis gave us a very simpler manner in which we could depict the valence electrons, right, in the outermost shell, and these were known as what? These were known as Lewis electron dot symbols. Lewis symbols. We just studied that the formation of the bond that depends upon the valence electrons, right? In order to show the valence electrons, Lewis suggested that we can show the picturization of any atom by drawing or by putting the symbol of the atom and surrounding it with dots, and these dots, it represented what? It will represent the number of electrons in the valence shell. Like let's take a very simple one, which is hydrogen. So hydrogen has only 1 electron in the outermost shell, so it can be depicted like this. When we're talking of lithium, lithium also has only 1 electron, right? Then we go on to the next one, which is beryllium. Beryllium has 2 electrons. Okay. Then next we go to boron. Boron has 3 electrons. Okay. Then after boron we go to carbon. कार्बन has 4 electrons, right? उसके बाद हमारे पास आ जाता है नाइट्रोजन. नाइट्रोजन has how many? 5 electrons. So 5 electrons can be shown like this. Then we have oxygen. Oxygen has 6 electrons, which can be shown like this. And fluorine has 7 electrons, which can be shown like this. Okay. Now, in order to show the bonding, let's take simple examples today, then we will do it in detail in the next lecture. In order to show the bonding, if hydrogen has 1 electron and the other hydrogen also has 1 electron, then what is this hydrogen going to do? It will share the electron to complete its duplet. In a similar manner, this will also share the electron. So there are 2 electrons which are being shared over here. 2 electrons form 1 bond. So this is how we represent hydrogen. If we need to form a bond between lithium fluoride, okay, so we know that lithium has 1 electron, whereas fluorine has 7 electrons. Okay, now in order to complete this electron over here, to complete the octet, lithium has to donate this electron. So as a result, lithium donates this electron to go to an inner electronic configuration of 8. Okay, and fluorine has 7 electrons in the outermost shell. So the atom which is losing the electron, that gets a positive charge, and the atom which is gaining the electron will get a negative charge. Okay? Similarly, if we are forming BeF2, Be has 2 electrons over here, it will forego its 2 electrons to 2 respective fluorines. Okay? समझ आ गया? Then when we are talking of BF3, in case of BF3, 5 electrons, 7 electrons fluorine has. So this boron that is going to share all the electrons of fluorine, the single electrons which are present, and fluorine that is going to share the electron, 1 electron each of boron. So this is how we can show the molecule. So we have and fluorine. Okay? So this is what Lewis dot structure is. Now Lewis dot structure के बाद there was a theory which was put forward by Lewis and Cossel. Theory was put by Lewis and Cossel. This theory that is known as electronic theory of valency. This is known as electronic theory of valency. Now what does this theory say? Number 1, you can write down valency of an atom. Valency of an atom depends upon the number of electrons in the outermost shell. Number of electrons in the outermost shell. Number 2, electronic configuration of noble gases is stable. Electronic configuration of noble gases is stable. That is, they have 8 electrons in the valence shell. Therefore, we say that noble gases, they are chemically inactive, or another word which we can use over here, they are inert. Right? That is, noble gases, because of 8 electrons, they are chemically inactive or they are inert. Right? Then number 3, atoms with less than 8 electrons. All atoms having less than 8 electrons in the outermost shell, they are chemically active, which means that they can participate in the chemical reactions. Right? Now, why are they chemically active? Because they have a tendency to complete their octet or to get 8 electrons in the outermost shell so as to become stable. Okay? Then number 4, the octet can be completed. The octet can be completed by 3 ways. Number 1, either by sharing electrons or by transfer of electrons. In case of transfer of electrons, we mean Either an atom will accept electron or an atom will lose electron. Okay? So in this case, corresponding to all these ways which we have done over here, in this chapter we are going to study three kind of bonds. If sharing of electrons is taking place, the bond that is known as covalent, right? And if transfer of electrons is taking place, the bond is known as electrovalent or it is known as ionic. Then we are also going to study a special kind of bond over here which is known as the coordinate covalent bond. Okay? So let's go on to the first kind of bond. This was the introduction of the chapter. We go on to the first kind of bond which is the electrovalent or ionic bond. Which is the electrovalent ionic bond. Okay. Now what is electrovalent or ionic bond? As we just said that this bond that is formed by transfer of electrons. It is formed by transfer of electrons. Right? अब ये transfer of electrons कहाँ से कहाँ होगी? The transfer of electrons that is taking place from an electropositive element to an electronegative element. Right? What is an electropositive element? Electropositive element means that it has a tendency to lose electrons in order to complete its octets, and such ions or electropositive elements, when they lose electrons, they form positively charged ions, and these positively charged ions, they are known as cations, right? As for example, we have Na positive. Na positive has a tendency to lose one electron to go to its octet. Na has how many electrons? It has 11 electrons. ठीक है? So अगर आप electronic configuration Na की देखोगे, in the outermost shell, it is going to be 3s1. Okay. Otherwise, the electronic configuration is 1s2, 2s2, 2p6, 3s1. Now, if it loses one electron, it will enter a configuration which is the nearest noble gas configuration. Therefore, it has a tendency to form Na positive. Okay. Similarly, beryllium has a tendency to form Be2 positive, or we have magnesium, right? So these are known as cations, which are formed by loss of electrons. In case of electronegative elements, we say that electronegative elements are those elements which have a tendency to gain electrons, right? Gain electrons का मतलब that they will become negatively charged, and if they are becoming negatively charged, they are known as anions. For example, all the halogens, they have 7 electrons in the outermost shell. Therefore, they have a tendency to gain one electron and form electronegative ions. So basically, it is the electrovalent or ionic bond. It is the electrostatic forces of attraction between the cations and the anions. The cations, they are positively charged, and anions, they are negatively charged. They are attracted by one another. Therefore, this bond that is formed, that is known as electrovalent bond, that is known as ionic bond, and we give another name to it. It is also known as polar bond. Okay? So let's take a few examples. For example, we have potassium. Potassium has 1 electron. Chlorine has 7 electrons. So potassium has a tendency to give this electron to chlorine, as a result of which a bond formation that is going to take place, which can be represented like this. Okay? Similarly, if we have calcium, calcium has 2 electrons, and oxygen has 6 electrons. So calcium has a tendency to give both these electrons to oxygen such as to form a molecule Ca2 positive and O2 negative. Okay, then similarly we can also give an example of MgCl2. Magnesium has 2 electrons, chlorine has 7. Okay, so ये magnesium is going to give 1 electron here and the other electron here, such that we have Mg2 positive and Cl2 negative. Okay ji? So this is what our ionic bond is. Now to form ionic bond, we say that there are certain conditions which are required. So let's study the conditions. Conditions for formation of ionic bond. The first condition is that the number of valence electrons in the element in order to form ionic bond should be at least 1, 2 or 3, okay? Or they should have 5, 6 and 7 valence electrons. If 4 valence electrons are present, as in the case of group 14 of the periodic table, they preferably form covalent bonds rather than forming ionic bonds, right? So they should have valence electrons of 1, 2 or 3 or 5, 6 or 7. Clear? The second condition is, this is the first condition. Second condition is that there should be electronegative difference. There should be electronegativity difference. ठीक है? So electronegativity difference होगा तभी ionic bonds are formed. We had calculated the electronegativity differences in the last chapter. Okay, so if the electronegativity difference between the two combining atoms that is equal to 2, only then ionic bond will be formed. Okay, we have calculated the electronegativity difference by 2 scales. One was the Pauling scale and the other one was the molecular. So if the electronegativity difference between the two combining atoms that is coming as 2, only then the formation of ionic bond that is going to take place. Right? Then third is there should be overall decrease in ionization energy. In energy. Okay. So what are we saying? Third is that there should be decrease in overall energy. We say that when an ionic bond is formed, there are 3 types of energies which are acting. Okay, the first energy over here, that is the ionization energy. Ionization energy. We know that the ionization energy, that is the energy required to remove the electron from the outermost shell of an isolated gaseous atom. Okay? So ionization energy, because it is the energy required. Therefore we say that this energy should be positive. Okay, now because this energy is positive, and over here when the electrovalent bond is being formed, formation of cations is taking place over here, right? We say that lower the the bond is formed. Right? Lower the ionization energy, more easily the bond is formed. Okay? So we say that the alkali metals, they have the lowest value of ionization energy in the periodic table. Therefore, alkali metals, they have the tendency to form ionic bonds to the maximum. Clear? Then second energy which we require over here, that is the electron gain enthalpy or electron affinity, right? Now the electron gain enthalpy, if we define it, it is the amount of energy released when an electron is added to an isolated gaseous atom. Okay? So because it is the amount of energy released over here, therefore we say that this energy that is going to be negative. Okay? So in order to form an anion higher, or in other words more negative, the electron affinity, more easily the anion will be formed. Okay? So we are saying lower the ionization energy, more easily the cation is formed. Higher the electron affinity, more easily the anion is formed. Now in addition to this, now we have a cation over here, we have an anion over here, both have to come together now to form the bond, right? Now in order to form this bond, there is another kind of energy which we require, that is the lattice energy. What is lattice energy? Lattice energy is again the energy released when one mole of cations, one mole of positively charged cations plus one mole of negatively charged anions, they come together to form a crystal lattice. Okay, so this energy, because this is also released, so this energy, that should also be negative. Okay, so we say that higher the lattice energy, more stronger is going to be the bond. Okay, now discussing about these three energies over here, we can see over here that this is positive, this is negative, and this is negative. And we are saying that there should be a decrease in overall energy, or in other terms, when we say that we add up all these three energies, the final result should come in negative. Okay, so electrovalent bond or ionic bond is stable only if ionization energy plus electron gain enthalpy plus lattice energy, when we add up all these energies, we are getting a negative value of energy, then the bond formation can take place. Okay, now when we are talking of lattice energy over here, the lattice energy depends upon the following factors. Factors on which lattice energy depends. Lattice energy depends upon the following factors. First, it will depend upon the size of the ion. We say smaller the size. Okay, we are saying smaller the size, more is going to be the attractive power, because the nucleus that is going to attract the incoming atom more effectively. Okay? So smaller the size, greater is the lattice energy. ठीक है? Then second, the lattice energy depends upon charge. So in case of charge we say greater the charge, greater is the ionization energy. Sorry, greater is the lattice energy. Okay, so with size the lattice energy that is going to be inversely proportional, whereas when we are talking of charge, then with charge the lattice energy that is going to be directly proportional. So what are the conclusions which we get from this section? Number one, ionic bond, it is purely electrostatic in nature. That is why we call it as a polar bond, right? Then number two, its formation is favored by low ionization energy, high value of electron gain enthalpy, and high value of lattice energy, right? So summation of all these three energies, that should be negative. If the summation is not negative, the formation of ionic bond is not going to take place. Okay, then we also say greater the electronegativity difference. Like for example, if we are taking alkali metals and we are taking the halides, they form the most stable ionic bonds, because alkali metals, they are electropositive in nature, whereas the halogens, they are electronegative in nature, the most electronegative. So halogens, combination of the alkali metals and the halogens, they form the most stable ionic bonds. Okay, greater the difference in electronegativity, better is the formation of the ionic bond, right? Then capacity of an element to attract or to donate the shared pair of electrons, that is known as what? That is known as the electrovalency. Okay? For example, when we are talking of alkali metals, they are donating one electron. So its electrovalency, that is going to be 1. Clear? In case of alkaline earth metals, we just saw, like in calcium, they are donating 2 electrons. So their electrovalency, that is going to be 2. Okay? Samajh aa gaya? So this is all what we are going to do for today. Okay?